To start, we're going to go through what a catalyst actually is. So in a reaction, what you might see for a catalyst is something like what's shown on the screen here. So in this reaction, we have ethene plus hydrogen, and then we see this platinum over the arrow. This is a catalyst. Catalysts are species that are not consumed during the reaction, so they end up being regenerated. And so they help a reaction occur with a lower activation energy. And the way that they do this is by providing an alternate pathway for the reaction. So a catalyst is neither a reactant nor product. It's regenerated during the reaction, and so it's always in excess. On a potential energy diagram, so here we have a potential energy diagram for an endothermic reaction. We see our reactants, our activation energy to an activated complex, and then our products. What will happen when we add a catalyst is that activated complex is going to be of a lower energy. So our original activated complex has quite a high potential energy, and our catalyzed activated complex has a significantly lower potential energy because the reaction has taken a different pathway, and so our activated complex is going to be different. Because that activated complex has a lower energy, the activation energy of both the forward and the reverse reaction drops. So we can see here that our original activation energy is quite high, and for the catalyzed reaction, we have a fairly substantial drop in activation energy. Same with for the reverse reaction. And what that means is that more molecules will have enough energy to actually react once they collide. And so on a potential energy diagram, a catalyst just looks like the exact same curve, but shrunken down a little bit. Really important to note, the enthalpy of our reaction does not change when a catalyst is added. So when a catalyst is added, it doesn't change the energy of the reactants or products, so the enthalpy of our reaction does not change. And the reason that more molecules have enough energy has to do with something called a molecular distribution of energies. So typically, we would have a percentage of molecules on the y-axis and then energy on the x-axis. And so our molecular energy distribution would look something like this, where some molecules have really high energy, but most have fairly low energy. And for a typical reaction, the activation energy might be somewhere here. And what that means is that only the molecules with energy above this threshold are able to actually undergo a successful reaction. When a catalyst is introduced, that drop in activation energy that we see means that more molecules are then able to undergo a reaction. So once we've introduced a catalyst, we now have a significant proportion of our molecules with enough energy to actually undergo a successful reaction. And what that's going to do is it's going to increase the rate of the reaction. um, because more of the collisions that occur are going to be successful.